Well, hello from Emerald Hill Skies. My name is Doug and I'd like to welcome you again tonight to another live stream. We're just about on the outskirts of Louisville, Kentucky, where we use a RASA 11-inch scope from this observatory. It's a Pier-Tech Tele-Station 2, and we use this telescope. It's a 11-inch Celestron Rowe-Ackermann Schmidt it's like a Schmidt camera telescope. There's no eyepiece, and basically it operates by feeding us the data through this rig rack that's at the bottom of the scope. And as an astrograph, you just have to look through the scope and see what the camera sees. And so that's why astronomy is kind of a team sport here at Emerald Hill Skies. And when you observe with us, you're looking at the stuff that's coming from this camera that you see on the business end of the scope. It's a ZWO ASI2600, and it's a one-shot astro-cam, It's there on Octopi-Astro camera interface on the front of the corrector lens that's there at the front of that RASA telescope, 11-inch aperture. And the sky is really beautiful tonight. It's nice and clear. We'll have about an hour without the moon. And then the moon will come up with a vengeance at 89%. The observatory is already warmed up out there, and the scope is, in fact, already pointing at our first target. And that target is right here over the east-southeast. Let's see if we can zoom in a little bit more. It's right here, the NGC 4570. So again, for context, NGC 4570. We're right here, kind of in the arms of Virgo, in between the arms of Virgo. How about that? And if you're familiar with the Little Dipper and the cup, if you could just spin ahead off the arm of the Little Dipper in the direction of Virgo, and that's where we'd be pointing. Altitude about, maybe 36 degrees above the horizon. And you can see on the screen there the horizon here, and then we've got the tree line in a kind of a photorealistic panorama here. And I'm actually sitting inside this building right here, and that's my truck. And in the photorealistic horizon, my truck was parked there, and in fact, that's where it's parked tonight. This actual line here is a polygon that's a little bit closer to the real horizon, I think. So you can see kind of where we are. We're a little bit south of east, so east-southeast, I guess you could say. This galaxy is kind of exotic. It doesn't even have a picture in Stellarium, the planetarium software we use. But we've been on it here while we've been warming up. So we've been on it about 23 minutes. And you can see a nice bright core. And you can see the complete disk, the arms here. In fact, this reminds me of that galaxy that some people call the Twilight Zone galaxy. It looks like a flying saucer, doesn't it? And so we've already got our first object viewed, and we're ready to go on to the second one. Let me see who's on tonight. We've got Mike. Mike, I wish we could finish the Herschel 400, but I think there are 3 objects that are off-season that we're going to have to pick up at another time in the year. But we'll be very close, I hope, by the end of the night. Ray, good to have you on from Arizona. Mike's in Georgia. And Ray, you're from out there in Arizona. I don't know if there are others who are on. It looks like there are 7 or 8 on tonight. If you don't mind telling us where you're observing with us, tell us the site where you're observing from. We'd love to hear. So that's going to wrap it up. We'll do a quick little screenshot of here, just to save this shot. We might show you this particular part of the sky is really galaxy rich. You see the galaxy there, and then there's another one up here. Wonder if we can tune this a little bit lighter just so you can make those out. Yeah. There's another one up here, another galaxy there. In fact, we'll turn on deep sky image annotation real quick because it's quite a galaxy-rich part of the sky. All right, let's head to the next target. We're going to try to hit 24 targets tonight if we can in 2 hours. So let's head for the next, which is NGC 4030. And we'll slew to it here. NGC 4030. And tune up our chart to it as well. NGC 4030. And let's see. I don't think I'm going to do the titles tonight down on the screen. I think we'll just run a little bit faster without that. And let's see, we've got Ricky with us. Good to have you here, Ricky. David, good to have you back from Michigan. Clear skies up there as well. Nice. Yeah, we've got nice clear skies here this evening as well. You can see there, it's a beautiful, you see the Big Dipper off to the left. Let's see, Big Dipper over here. It's a beautiful night. Until the moon comes up, and then it's going to be pretty bright. So if you're familiar, you've been on the channel before, if you're catching this for the first time, then you know that what we do is we slew pretty close to the object. The first few objects, we actually tune up the mount a little bit. The mount is the hardware that points the telescope for us. And you can see we're pretty much, I think, spot on here. The sequence that we have programmed in kind of tries to, it uses a technique called plate solving, and that captures a picture of the night sky and then compares it to the software's memory of this part of the night sky. And using the stars as guideposts, it actually synchronizes the mount very precisely. So the object can be right here in the middle of the screen. And every time it does that, it also makes an adjustment to the telescope's, to the mount's ability to find things. So as you go through the first half dozen objects, the mount gets more and more accurate with each find, with each go-to. This is NGC 4030. And what we use is Stephen James O'Meara's Herschel 400 Observing Guide. And we use that kind of as our guide here. So it's going to take us to page 133. And oftentimes, Steve O'Meara will help us learn just a little more about the object. Here he says it's a small but somewhat obvious spiral, and it's nestled between two 10th magnitude stars, fairly condensed. And it's obvious to the eye as a singular spot of interest. But it's only 1 arc minute wide in the core, maybe 3 arc minutes wide in its glow. Just talks about it in his 4-inch scope as kind of a halo. He likes doing these targets with a 4-inch scope because he wants to be, you know, modest with what he would see. But you can see in an 11-inch scope, we can see just a little more detail in this. We're starting to see the arms out here that are kind of flailing out. There's a little bit of an arm there. And this is just after 2 minutes. If we pump up the mids a little bit more, it makes you wonder if maybe these stars aren't in those trailing arms. David Simard, good to have you from St. Cecile. I think with plate solving, I think we're using ASTAP, Ray. Let's go up and check that just to be sure. Let's see. Plate solving. ASTAP, yes. That's our first priority plate solving solution is ASTOP. So it's a beautiful little galaxy there, isn't it? You can see some of the newer stars forming up in those arms. This is at about 150% of our camera's ability, so we're picking up just a little bit of mosaic, but not too much, huh? Seeing more and more detail in there. Look how those spirals can make out that spiral trailing arm there and this spiral trailing arm here. So we'll snap a picture of this and head to the next one. It's a beautiful little galaxy. This is NGC 4030. Let's add a written observation of this. And we use Deep Sky Planner 8. And we'll say after just 3 minutes, we could make out quite a bit of detail in the flailing arms. We could see a couple of stars that looked like they were recently formed, along with those 2 10th magnitude framing stars. All right, that takes care of 4030. And now we'll head to the next target, which is going to be 4179, NGC 4179. Oftentimes, if you guys want to use Wikipedia or whatever to look up data, we can use that data to be able to plot just a little better observation. You can see the scope moving just a little bit, not a lot of movement there, not traveling too far in the night sky. Seems like the scope is settled now. And for context again, this is 4179. We'll bounce over to see where we are in the night sky. And you can see we're still in the constellation of Virgo. A little bit more along this arm. Once again, this is another one of those exotic targets without any kind of art, any kind of captured astro image there. Again, we're just right over the top of the building here, east-southeast facing. And let's see what you guys are saying here. Wiki says it's about 64 million light years away. Oh, okay, so Ray, you use ASTOP as well. And we'll queue up an observation here, so we'll be ready to roll. This Deep Sky Planner I really like. I did a video recently comparing it to Astro Planner, and I kind of like the beauty of it, and to me it's just a little bit more logical the way it works. Okay, so the first thing we do, Ray kind of put me onto this. Sometimes we have to use this display histogram over here to do a reset of that for some reason, and I have that built into the sequence, but for some reason it doesn't seem to take effect very well until we're stacking. And then what we're doing down here at the bottom is live stacking the image. Boy, it's a tiny, tiny galaxy there, isn't it? And by live stacking, we mean we're taking picture after picture. We're exposing these at 20 seconds, and it's a gain of about 100. And we stack one, well, the software, SharpCap 4.0, stacks one image on top of another. And as it's stacking them inside the software, it actually averages the light sources that it picks up on a pixel by pixel basis. So that makes the brighter pixels brighter and the darker pixels darker. So a lot of this kind of grainy look that you see out here in the sky, that will continue to darken because every single image that it takes, that grain, it's sort of like mists a little bit in the night sky because it's not really something we can photograph. It's just photographing light pollution, and that's always pixelating. So as that stuff gets darker, it creates more contrast. The signal-to-noise ratio of the photograph that we're looking at here real time, it improves. And if you're familiar with signal-to-noise ratio in audio, you know that you want one that's a high signal with low noise, and that's what we're trying to get here in the scope as well. High signal with low noise. Once again, this is a galaxy that's kind of on edge. Let's look at it here, 4179. Oh, it's right here beside. Small, thin, fairly dim lenticular galaxy. And he says it's virtually impossible to see at low power with any light pollution at all. In fact, he says, with a 4-inch, it just kind of looks like a pip of fuzzy light, like a fuzzy star. And that's just the galaxy's nuclear region. It's a very tiny needle of light at 72 power. You have to use averted vision, he says. Through larger telescopes, the core gets brighter, and the galaxy is quite the attractive edge-on object. So we'll be able to see here edge-on, and this one's 57 million light years away. That's ASRAY, thanks. And it's an edge-on, a thin needle of light with a bright core. Another flying saucer. Just looks like aliens that are coming home. Pretty cool. All right, let's do it. Boy, I don't think this is going to make a great photo because it's so tiny. Just 1 arc minute. But we'll snap a picture and head on to 4754. This is NGC 4754. 4754. And I don't know how much scope will move. Not very much. Boy, it's just captivating the night sky, isn't it? 4754. So again, we're in Virgo. You can see in our photorealistic horizon, we're looking over the top of the observatory. Again, we're east-southeast. And there's the location of 4754. You saw the RASA in the plate solve, zooming in on it, synchronizing with it. But again, there's no artwork. It's such an exotic galaxy, not something that Stellarium has in its library. We could add it, but we would have to add it. Okay, we'll catch back up with you guys. Ken Allen, good to have you aboard. About 56 million light years away, Ken says. $53 million. We'll get our light years in. All sorted out, won't we, guys? Man, it looks like $47.54. Is that another flying saucer? Or did we just look at that and now we're looking at this galaxy, I wonder? Let's use deep sky image annotation. Yeah, 4754 is this one up here. You notice how it's just slightly off. We can fix that if you want by going here and saying plate solve, solve only, and it'll resolve. And when it resolves, it'll make up for that slew that we just did be a little more precise in its aiming. Eyeing about 56 million. That was a pun. I'll wave it. A flying saucer. Yeah, I mean the flying saucer shape. Yes, 2 for the price of 1. Right, Azray. Okay, so now with our plate solving, we should be, yeah, spot on. So here's 4754 here. Now we'll zoom in. This one's not as obvious as a spiral. This looks more like a, I guess, what would we call this, elliptical? 4754. I don't know if you have to go back the index to find this. 4754 is on 154. Ah, yeah. It's a small but condensed galaxy. Boy, it doesn't say much about it. Bright circular core, about 2 arc minutes across. The glow becomes gradually, then suddenly much brighter in the middle, though not to a star-like nucleus. Dim and extended outer envelope. It's a spiral. We're in Coma Berenices now. But boy, not a lot of detail in those rings, huh? We're at 200% of our telescope's optical zoom. Barred lenticular. Yeah, that's what I was going to say. Lenticular basically means you can't make out the spiral arms. So we should have just looked in the last location. Boy, that's a cool needle galaxy, isn't it? All right, so we'll say about 4754. Barred lenticular, around 53 million light years away, Ray. Not a lot of detail in the arms. Kind of makes you wonder why Herschel was able to pick this one out, doesn't it? Why did he see this as a galaxy? And these he could detect were star pinpoints, but this, he could tell it was a little bit fuzzy. He must have had a good seeing night tonight, huh? All right, off we go to 4762 now. 4762. And it's a live view of the scope there. Still traveling here in Virgo area. Lots of galaxies in Virgo, huh? We're just on the Virgo's right arm now. (4762). Here it is. I wonder if that was that. That was that needle, wasn't it? Right there beside it. 4762. In other words, we were already looking at it. I should have just left it and done the 2-for-1 thing like you talked about, Ray. Very close to see it. An entire cluster of galaxies. Right, Ray is saying Virgo's full of galaxies. This again reminded us of a flying saucer, except this time doing a wheelie. Boy, it's beautiful, isn't it? I mean, just look at it kind of suspended there in the night sky. Ray's saying I should crank up the gain, but this telescope does well with 100 gain and 20 seconds. I don't have I don't actually have any flats shot at higher gains now because I'm just so happy with 100. There are more dynamic settings on this camera at a gain of 100, and really, after just 2 or 3 minutes, you can pull in so many objects, even with a gain of 100. And I just noticed that it seems like the grain is so much less on this camera. Let's see, again, needle-like, bright core, and bright edge too. Look how bright, look how the galaxy stays. This is NGC 4762. Look how it stays bright all the way out into the disk. This inner bulge doesn't seem to bulge quite as much, does it? Well, that's just 2 minutes, but we already have a good impression of that galaxy, don't we? Let's head to the next one, which is 4698, NGC 4698. Again, this is a live shot of the telescope looking over its, kind of looking over its shoulder. And you can pretty much tell what direction the telescope is pointing by imagining that this is pretty much the axis looking up toward the north celestial pole. So if the telescope's aiming up and to the right, I mean, imagine that we're looking with our back to south, and we're looking like along what would be like the barrel of a rifle if we aim the rifle at the North Pole, see? So if the scope is pointing up to our right and up, then we know that it's aimed at the east and up, you see, pretty much. So when we go over to Stellarium, sure enough, here's the compass point, the bearing east here at the bottom, and there's southeast. And we're at an altitude of 35 degrees right here. And this is called the Paper Kite Galaxy. The Paper Kite Galaxy. NGC 40. Let's see, I thought we were aiming at 4698. Show chart. Ah, here we go, 4698. Let's look at our bearing again. Still east, southeast. And 4698. No nickname for this one and no image. Again, it's very exotic. So there's a 60-second view of it. We'll zoom in on a very early look at it. 4698, Ray says, is a barred spiral 55 million light years away. Ray, it sounds like you have a 2600 as well. So if you crank it up to 350 gain, then you must like that higher gain setting. Let's see, 56 million light years away, barred spiral. Ray, thanks, Ray. This is an odd shape, 4698. 4698. I'm going to go back to the index again and find this. 4698 is on 158. Small but somewhat apparent galaxy. Core is very bright. Very nice elongated glow, about 1.5 arc minutes in length, with a star-like core, a small cocoon of fuzzy light whose slightly tapered edges seem more pronounced than its interior. Wonder how long we'd have to sit on this to be able to see more of that detail in the spiral. So far it's just that fuzzy cocoon. That's a good way to describe it. That's 3 minutes. A fuzzy cocoon, according to O'Meara, 4698. Well, I think we're going to call it there. Head to the next one, which is 4527. (4527). So you can make out the Big Dipper there to your left. We're kind of in the back side of the handle, aren't we? Still looking off to the east. (4527). Look where we are. We're still right there in the center of Virgo. No artwork. I think I'm in a habit now, Ray, of doing the auto stretch in the display histogram and then doing the auto stretch in the live histogram. I think I'm pretty much in the habit of doing it every time since you've been sort of reminding me of that. (4527). Tonight, I got here right about the time Mercury was setting, and I was in a hurry. So when I opened the roof of the observatory, you can see it's a roll-off roof. And I do have a garage door opener. It's like a gate opener, you know, that I use because it is very heavy to try to push that roof off at some leverages. Kind of like a filing cabinet drawer. You know, when the weight is out here, the leverage is such that it's pretty heavy. So I do have a gate opener on that roof, but I don't yet have what you might call an automated set of sensors to help me turn the gate opener off automatically. I don't have that. And what happened was I was in such a hurry that I opened it, but not as much as usual. And I noticed that I didn't open it as much as usual. But I still was in a hurry trying to catch Mercury. Well, I came in and tried to salute a Mercury, and the front of the scope, what we call the dew shield, this black section of metal piping you put on the front of the scope, and it just stays on there all the time. But that dew shield caught on the roof. And I guess on this mount, I trust and I hope that there's some kind of a clutching mechanism, because it caught on the roof. So I had to go back out and free the telescope, first with the deck axis. And boy, I was feeling bad. I hoped I hadn't done any damage. Then I could start the roof closed and start it back open again and open it fully. And then, re-zero position the scope. Well, I guess it's working okay, but boy, I tell you what, having done that once, I don't think I'll do that ever again. I think once bitten, twice shy. I think from now on, I'll always make sure that the roll-off roof is completely rolled off. So here in this image, we've got 4536, which is our next image. And this time I'm looking first, so we don't have to queue this up twice. I don't see these other targets in the Herschel 400 curated list, but at least these two are kind of facing one another. I don't see 4533, but here's 4527 on the left, and there's 4536 on the right. So let's get rid of those annotation now. So they're kind of like a smaller version of the eyes galaxies. Wow, that's a pretty cool one. Look how wide those arms are trailing out. I bet this one's been interacted with, and I wonder if it's been interacted with this one. So this is 4527. In 3 minutes and 40 seconds, it pulled out that much detail. Let's find this 4527 is on 151. Moderately bright, spiral, more difficult to see in smaller scopes. Light pollution will greatly affect its visibility. We're at about Bortle 6, so quite a bit of light pollution. Modestly bright, slender ellipse, translucent quality to it. Nice. Becomes a difficult object to see in that it almost disappears, forcing you to use averted vision. But I got to add here, Stephen James O'Meara was not using electronically-assisted astronomy. He could basically just make out a small nuclear region and a very dim central lens. But look at the detail you can see with EAA. This is beautiful. Yes, I missed Mercury. Azray, I missed it. It was too low in the trees, about 5 degrees by the time I got there. Sorry to say. but we'll catch it before it gets away. April has quite a bit of good nights. I think it's going to be clear here Tuesday night and Wednesday night. We'll try to catch it one of those 2 nights. Let's see. We're going to say here, beautiful, what would you call that? Flocculent, is that what they call that? Flocculent nature of the disk at around, would you say that's 20 degrees? 20 or 30, let's say. 20 or 30 degrees edge on, which lets us see quite a lot of detail. And 49 million light years away ray. And then if we just spin over here to the other eye, look at this one. Much wider. Much wider arms. Almost looks like some kind of a ninja, you know, something you throw. And just to verify, 4536. Much wider arms. Looks like it's been affected by a galaxy collision. Pulled it apart. Let's see if Omira says anything about this. 4536, moderately large, though somewhat difficult. Light pollution will greatly affect it. He wasn't using EAA. It's 4 arc minutes long with little or no concentration. He wasn't using EAA. More difficult because the diffuse light spreads out. Still, with averted vision, a star-like core inside an oval lens gradually fades outward into a broad elliptical halo. See, he could not make out these arms in his 4-inch. But with EAA, with this 11-inch, we can see arms quite a ways out here, can't we? Look at that. It's almost like a weed eater that has, you know, the 2 strings flailing out. Like 2 strings flailing out from a weed eater. Like a propeller, yeah. Looks almost like a propeller. ASRAY. Pretty cool. 4536. I have a question. Toward the northwest, about 10 o'clock, is a bright light in the sky. Is it a planet or a satellite? That would be Venus, Andy. And it is bright. You're right. It's incredibly bright. You don't spell it with an X, though. Spell it with an S, huh? It is currently magnitude -4. So it's just screaming. You're right. It's right at the edge of our tree line. This is supposed to be the horizon, this polygonal line here. And I actually dropped the tree line down below the horizon for just exactly such a time as this, hoping against hope. that sometimes there'll be a patch of leaves in the trees that's kind of open. Like look right here, as the scope, you can see how low the scope is going. Look right here the way that in this part of the photorealistic horizon, see how there's an opening in the leaves? So I actually pull the photorealistic horizon down, just in case there's an opening in leaves. But up here at the top, where you see this polygonal line, that's supposed to be the horizon. Let's see how we did. Oh, I forgot to stop the live stacking. Excuse me, sorry about that. Let's go back to the default next target. And sure enough, that's exactly what's happening. We actually don't need that much time. We could probably do with 1 second or less. But look how it's in the trees, and that's why it's not showing us much detail, because we're actually peering through the leaves here. But it was very nice earlier. You can see, you can make out stars here through these leaves. And Venus is just in a place where you can't quite make it out. But it's still bright even through the leaves. Can you see the way the scope is sort of following it down through the leaves? With every 3-second exposure, you can see how fast the sky is moving. Looking at it with trees this close, it's almost an optical illusion how that it's... Because when it's far away, you don't see it move through the leaves that fast. Anyway, there you go. Next target, 4636. Stu, welcome. Family Easter stuff. Stu, you get a free pass on Easter in New Zealand. Tell us in Tauranga, are there any special kind of traditions in Tauranga, New Zealand? Do you guys hide Easter eggs, for example, in New Zealand? Or do you hide like kiwi fruit instead? Something like that? So let's see, it would be around 11 a.m., like 10 minutes to 11 there, right? That's so fun. Did you notice, gang, when Stu comes on, he feels like he has to apologize for being late. I think that's awesome. It's like he comes with the RASA. It's like he's built in the observatory. That's awesome. All right, so now we took a little detour, Stu, because we wanted to see if Venus was in our sights, and it had just come down below the tree line, but it gave us a chance to show why we leave the polygonal line up and the trees down, because sometimes you can see through the trees in a little patch of clear space between the leaves, and you could actually see the stars. It actually made a really good example of why we bumped that tree line down. Boy, not a lot here except a bright little fuzzy core, huh? This is 4636. we actually do have an image of this, and in the image you can see exactly what we're looking at. Just a fuzzy star with a halo. You can also see where we are. We're still like in the head of Virgo, which is east-southeast. This would be just a little better with the sky a little bit darker, because that halo would show a little better. NGC 4636, elliptical galaxy, 55 million light years. Elliptical takes some pressure off of us because I couldn't see any spiral arms. Elliptical galaxy, 55 million light years away. Fuzzy, star-like core, 4636. 4636. All right, I think we're going to head to the next one here. Let's go to 4665. $46.65. Beautiful sky tonight. $46.65. $149. Very small and round. Fuzzy. Well condensed. 2 arc-minute wide circular glow by 1.5 minute. Oh, it's 1.5 degrees northeast of an 11th magnitude star. Because it's close to this 11th magnitude star, he says, they almost look like a larger extended object. But at 72 power, you can separate them. In a large scope, you might see the dim bar. A dim bar. This is 4665. Boy, these are tiny objects. Tiny. So there's the 11th magnitude star. Oh yeah, we can already see the bar at 60 seconds. Electronically-assisted astronomy amazes me. Take a look at that picture And then I'm going to show you the picture that O'Meara shows. Is that it? 40? Yeah. It's hard to adjust it. Oh, there we go. So that's the picture O'Meara shows. And look what we see after 2 minutes. It's amazing. It's exactly the same as the astrophoto. Elliptical. Is this ASRAE? Is this the one that's 55 million? He doesn't have a distance. Boy, it'd be so hard in Virgo to figure out which galaxy you're looking at, wouldn't it, without EAA? We made out the bar after just 60 seconds. Looked like a very thick flying saucer. This is flying saucer night. 4665. All right, let's head to 4643. 4643. We're ready for NGC 4643, Ray. There's 4643. Looks like another version of the same thing, doesn't it? I'm sorry, 4643 is down here. 4636 is what we probably just looked at. This is what we're going to go see now, and there's no artwork for it, no image. So let's take a look and see what we've got here. 4643. Let's see what O'Meara says about it. 4643. Page 150. Very small, very dim, tiny fuzzy star. Looks like Saturn. May only appear elongated. Hmm. (4643) lenticular, 62 million light years. There's a little bit of anticipation, isn't there? During those 20 seconds waiting for the first image, you're kind of thinking, what's it going to look like? And then it pops into view. Sure enough, it's Saturn. It's the Saturn galaxy. Looked like Saturn. Edge on to the rings. As Ray said, it was 62 million light years. Stu says, family's leaving soon, then I'll be with yous. Lenticular. You get a free pass, Stu. Spend time with your family, man. Easter comes just once a year. That's at 329%. If that helps you see how small this thing is. There's 150%. You can almost hear the Twilight Zone music in the background. Anybody remember Twilight Zone? That's 2 minutes. Let's head to the next target. Oh wait, did we finish our observation? No. Looked very much like Twilight Zone. (4666). (4666). Super Wind Galaxy. The Super Wind Galaxy. Why would we call it the Super Wind Galaxy? (4666), 148. Small but moderately bright elongated galaxy. Might have used avert vision. It seems like he says it on every object. Very nice in a dark sky. It's a 4 arc-minute long needle of light. That's going to look giant compared to the ones we've been looking at. Best seen with avert vision. Bright elongated core. Northeast sector is a little brighter than the southwest sector. Maybe you'll see mottled texture if you have a larger telescope. Kind of looking forward to this now, a little bit larger. Stu says, I'm not kicking them out or anything. They're going home. 54.8 million. Wiki has a nice pick. Okay. We'll go look at that in a second. Azray, thanks. Wow. nice. Okay. Boy, there's some cool stuff here. I wonder, that's 60 seconds. $46.66. Several galaxies and a satellite here. This is cool, these three stars close together here. Wow, that's beautiful. Look at that. Wow, 120 seconds. After just 120 seconds, we could already see a mottled core, a mottled disk, and make out some cottony nature of the arms. 54.8 million light years away. Cool little asterism out to the side. Three little stars side by side. Here's that. Here are those three little stars. That's cool. Not even labeled, but they're very cool. Four minutes. Unfortunately, we have to go on, but look how beautiful that is. Look at the fiery core we can see here in the middle. Another one just below the three stars, right? Another galaxy here, exactly, Ray. Good eyes. Nice. This is with the 2.2 meter telescope at La Silla Observatory in Chile. It's a starburst galaxy. It means there are a lot of star formation and likely to have supernovae. 4668 down here. That's beautiful too. Gorgeous. Here are those three little stars we saw. there's that 46, this little galaxy here that Ray pointed out. (4668), yeah, this is 4668. Beautiful also. Amazing view in the wiki article from the 2.2 meter scope at La Silla. 2.2 meters, so that's about 7-foot wide aperture. A little bit more than our RASA has. But still, this is, we're not complaining, are we? Let's go to NGC 4900. NGC 4900. Stu's saying that that was his brother who got him into astronomy when he was a kid. He was most impressed to hear of our Messier Marathon. Nice. Don, good to have you here, Don. Glad you stopped by. Yeah, that's what we need, Ezra. 2.2 meter scope, right? No complaints about either of your RASAs. You have the 11 and the 8. Let's go out to the SEDS page. Let's see. I don't know which one of these. Sorry, that's so bright. These are scheduled. Let's see. Here is where people were scheduling their marathons. He just doesn't have any of the results posted yet. He'll get them eventually. You could just get a bunch of 8-inch mirrors and hack your own 2.2 meter aperture. How many 8-inch scopes would that take? NGC 4900 is a barred spiral galaxy in the constellation Virgo. It was discovered by William Herschel on April 30th. (1786) is a member of the NGC 4073 group of galaxies. Nice, look at it. Is that it? How interesting. (4900). (152). Oh yeah, how interesting. Very small and dim. You'll need to make a slow and careful hop to it, so be patient. It's a tiny 2 arc-minute wide diffuse glow next to an 11th magnitude star. Yep, we can see the star. It's an intriguing sight, since the 11th magnitude star sits on its southeast flank, mimicking a supernova. The disk appears to form a ring around the nucleus. Otherwise, it's just a dim haze, like an asymmetrical fog around a star. Huh, barred spiral, huh? barred spiral, like fog around a star, O'Meara. "36 little 8-inch mirrors would make 2.2 meters. All right, Don, we'll have to hook up 36 RASAs. Let's see. At a cost of, what does a RASA cost, an 8 inches? It's $1,700. So let's multiply 36 times $1,700 for a mere $61,000. Now, after we did that, we'd have to figure out how to hook them all up so we could see the light gathering power of all of them. Okay. Look at this. Now, that's 3 minutes. It still just looks like a fog around a star. But look at this unique bar across it. This is like no other galaxy I've ever seen. Like no other galaxy I could remember. Pier-Tech, happy Easter. How are things in Florida, Pier-Tech? Next target is NGC 4546. 4546. Also in Virgo. I think 95% of these galaxies have been in Virgo tonight. Okay, so for context, 4546. There it is, right in the middle. And we're looking, oh, now we're outside of her right. We're in her right armpit. So we're looking south-southeast now. We are directly over her head. Directly overhead of where I'm sitting in this building. So let's, we're too high though to be able to see the building. Yeah. Oh, you might be able to see it down there. Let's look. Yes, you see that, see this light on down here? That's my light. I'm going to go stand in that window. I'll take my nice Surefire flashlight with me, and I'll shine my light in that window. Hello, observatory. Can you see me? I'm going to raise the blinds. Can you see? In fact, I'm going to open the window. Hello out there. Can you see me? That's funny. Oh, rats. Now I can't get the window hook. Oh, I guess, there we go. Well, I'm looking forward to seeing if you guys could, looking forward to seeing if you could see my flashlight. Could you see me? Okay, now you got me wondering how that would all work. I'll never do it, but an awesome thought, haha. Oh, with all the 8-inch RASAs? A field galaxy is a galaxy that does not belong to a larger galaxy group or a cluster and hence is gravitationally alone. field galaxy. So this is I wonder if that is a star in the arms of that, in that spiral disk. Boy, it's a small galaxy. This is 4546, NGC 4546. Let's see. Wish that neighbor would turn off his light. Dean. Make your flashlight a shooting star demonstration, Ken says. You saw the light, Azray. That's awesome. I can't wait to go back and watch the video. Is this 45, 46? Yeah. It's 45.6 million light years away. Stellar mass of 27 billion solar masses. That seems like a lot. 27 billion suns? A field galaxy, which means it's out in the cornfield. Not really. According to Stu, it's a galaxy that does not belong to a galaxy group. Gravitationally alone. Thanks. You guys are all, you were on Sky. You guys are all, let me know. All of you guys, you're all raising your arms, drumming your fingers. Okay, that's 45, 46. How interesting. Bright core, little star out here at the edge. Tiniest galaxy that... All right, next is 4845. (4845). (4845). This galaxy happens to be in Virgo. Again, now we're inside this keystone shape. (48, 45). There she blows. Webb wanted to maximize mirror area in the restricted payload area. 65 million light years. 48, 45. Books, welcome. How are things in Kangaroo Land? 65 million light years away. I don't ever use this auto color balance from the star colors. I always use the auto color balance from the histogram peaks. Is that what you guys use as well? Oh yeah, it looks like a supernova down there. This is 4845. .45 on 151. Spiral galaxy. Yes, ASRAE uses the histogram peaks as well. Very small and dim, lens-shaped. May not be visible at low power. Averted vision, moderate mag. Careful star hop. Not visible at all in 23 power. Under a very dark sky. At 72 power, could just be seen one arc-minute long needle of light trapped between two roughly 12th magnitude stars. There are those 12th magnitude stars oriented north, northeast to south, southwest. You might want to try increasing the power to at least 100 times, which will help separate the galaxy from the nearby stars. Tiny lens with a dim central concentration. There you go. It's another cocoon shape. Another cocoon shape. But we could make out a star that was properly placed to be a supernova. No way of telling whether or not it is, but here are those two 12th magnitude stars. And there they are. It's like a little triangle. And see that little star there is just properly placed to be a supernova. We're seeing some dust in the disk. Just some dust in the disk. Next target is 4753. .4753. .4753. NGC 4753. The Dust Devil Galaxy? The Dust Devil Galaxy, according to Stellarium. Lenticular, around 60 million light years away. Distinct dust lanes. Thus, I guess, the Dust Devil nickname. Holding down the shift key as I move these vertical bars, these histogram adjustment bars. This left bar that we always start with first, if you're new to plate, or if you're new to SharpCap, it establishes what you're going to define as black. So like here in this way of looking to star, we're defining as black the light pollution of Louisville. You know, there's a lot more light pollution in there. When we move it over just to the right of that peak, now we're defining as black everything above the light pollution. So now our RASA is trying to find out what is above all that light pollution, you see. And then this line on the right side is the mid-level, and we gradually move it closer and closer to the black level. And what that does is it takes the other kinds of light that were left after our base level of light, and it highlights them. It kind of pumps them up brighter. Boy, I'm not seeing a ton of dust lanes, but I guess we're still just 2 minutes and 20 seconds. Nice little satellite trail here. Then this line we very rarely mess with, huh? It's the white level, and it basically just needs to be outside of your data. So we can move the white level all the way over to here and not really affect the image much. If we start moving it into here now, we take away detail because we're whacking off and saying, make this the foundation of the white level. So really you can just pretty much leave that white line all the way over to the right. Now we can start to see a dust lane here. Right here. The smallest little dust lane at 3 minutes. At 3 minutes, we started seeing a pronounced dust trail through the arms. You can see why it's called out on the wiki picture of it. 4753. Oh. Yeah, the way it's got these kind of swirls, like marshmallow swirls in your hot chocolate. Yeah, it's just starting to see those. We have to come back for a lot longer time. That's 4 minutes, so we'll push on, but the Dust Devil Galaxy. Next is (2613) maybe. (2613). Black to the left and mids to the right. Yeah, that just, boy, look how much we're moving here. This is in PYX. What's PYX? 2613. '82. PYX, the Pyrex galaxy? 82. I mean, the Pyrex constellation? 82. Pyxis. How about that? I think it's my first time to observe anything in Pyxis. Boy, it's beautiful, isn't it? 2613. Wow. So for context, we are now looking, see, west-southwest, I guess. No, south-southwest. So for context, to give you an idea, you can remember this is over the hood of my truck. You can remember that way. There is a little bit of light dome in this part of the sky, quite a bit more over here, but quite a lot here, and that's in the direction of a town called Shepherdsville, I guess, an E-town. So it's away from Louisville, but there still is light pollution there. 2613. It's a spiral galaxy in the southern constellation of Pyxis, next to the western constellation border with puppies. In Pyxis, next to puppies. So Azrae, you had said to move the blacks to the left and the mids to the right. So that does produce a nice image of the sky, but it doesn't really, for our purposes in EAA, it doesn't bring out the galaxy as fast. Whereas you pump up the mids, that's 80 seconds. You're already starting to see the core there. It's just personal taste, isn't it? Just kind of everybody has a different way. Lenticular, 60 million light years away. Oh wait, sorry. Spiral, 78 million light years. Apparent visual mag 10.5. Faint, spindle-shaped supernova. NGC 261. 3 weeks ago. Oh, look. That satellite just came through, or maybe that was an airplane, exactly on the axis of the galaxy. We're going to have to clear that. That was already 3 minutes, too. I mean, he just obliterated it. He came through exactly on the axis. Bummer. Now, when you said 261, did you mean 2613? A real photobomb. Yep, definitely photobombed. Boy. Supernova and NGC 2613. March 20th. SN 2023 DTC. Wow, it's gotten quite a lot of publicity. All these reports. I'm having trouble finding a decent picture of it. Is that it? No, that's not it. Well, not seeing any pictures of it. I wonder if I just click on images. Not seeing any good pictures of it. So somewhere in here, huh? Well, let's save a screenshot here. Close up of it. NGC 2613, 4 minutes. Close up. And then we'll be able to go back and check it out later. Mag 18. So it's probably going to be one of these little stars there. So that'll be fun. When we find a picture of where it's pinpointed, I'll be able to go back and see if we captured it. All right, off we go into the wild black yonder. Supernova. 4699. 4699. Back in Virgo, by the way. The vinyl LP galaxy. The vinyl LP galaxy, according to Stellarium. $65 million light years. What happened to 4699? $46.99. Here we go. Now, $33 1/3. NGC 33 1/3. It would have been a better name. Don suggested that it should have been NGC 33 1/3. 65 million light years away. Why on earth would you call this the vinyl LP galaxy? Oh, maybe it does have a disk. It looks like a record, maybe. Straining to see it. Maybe it's going to come in right like that. Oh, sorry. Maybe it's going to come in like this. Let's take a look at 4699, 145. Small but very bright, shining at magnitude 9.5, 3 times smaller than M90. Intense star-like core. The lens is only 1 arc-minute wide. There's a 3 arc-minute wide elliptical envelope, though. Highly mottled. I call it vinyl LP galaxy because it looks like an old 78 LP record held at a slight angle under the moonlight. Do you think he made up that name? Wow. O'Meara made up that name and now it's in Stellarium. Yeah, you can kind of see as it gains more time, I bet that outer glow becomes more pronounced. You can sort of see it. O'Meara said it reminded him of a 78 LP record. He's showing his age. Yeah, they came before 33 1/3. You can definitely see it. I think once we get rid of the grain, it would be even more pronounced. That's fun. Okay. Next target is 5364. NGC 5364. Wow. So we're still in Virgo. that's sure beautiful in the whatever version. A grand design spiral, 54 million. Do you use the bilateral filter in live stacking? I don't think so. Should I be embarrassed? I don't know that I've ever heard of it. Stu is always telling us that he's copying and pasting. He's at least honest. Oh yeah, I can start to see this grand design already. Look at that, that's going to be pretty. Discovered by William Herschel, February 2nd, 1786, later listed as NGC 5364. Subsequently rediscovered by John Herschel and later listed as 5317. Well, father and son couldn't get their act together. Also listed as NGC 5317 because John rediscovered it. Okay, so bilateral filter. I use sigma clipping. Bilateral filter. Okay, so we just clicked it on. Should I be using sigma clipping all the time? Because it definitely says that it didn't stack a 1/4 percentage of all the pixels due to sigma limits. Hubble and Mount Lemmon. Okay, 5364. Oh my goodness. It is beautiful. .24" at Mount Lemmon. Oh my goodness. It's so nice. Let's get a 24" scope, guys. We got a ways to go on this one. That's 3 minutes right there. Let's see if we can punch it up some. Nope. It's going to take longer to get the 24" version. Rats! More aperture! More aperture! More aperture! And then there's this. Which is Hubble. Boy, it looks like a lot of star formation going on, doesn't it? Well, that's going to have to do it for tonight. And it is 12 o'clock. I know we usually stop after 2 hours, but this one would be a beauty if we stayed on it. Deserves another visit later for more integration. (720p) galaxy. 6 hours. Yeah, exactly, Stu. Just spend 6 hours, or Asray, it's just spend 6 hours on it. Catalina Oneg. So nice to have you checking in, Catalina. Catalana. That sounds like what, Eastern European or something? Maybe Catalana. What would that be? I'm afraid to guess because I don't want to insult you, but Catalana Oneg, would that be like Lithuanian or something? It's beautiful. You know, that's not bad actually there. We're starting to see some of the beauty in those spiral arms after 5 minutes and 40 seconds. Let's go ahead and save that. And our time is up. What do you guys think? We have 6 more objects, and that finishes all the objects that we can catch this time of year. And then there are 3 more objects I think that we're going to have to come back and get later. Because they're the wrong time of year for us. One of them is 26 degrees below the horizon, another is 38 degrees below the horizon, and another is 45 degrees below the horizon. So we're going to have to catch those later on. Those, actually there's one at 13 below the horizon. I bet we could get it Tuesday or Wednesday night. So we've got right now 6 more objects. At our 3-minute rate, that would be, if we could average 3 minutes, it's probably more like 4, isn't it? That would be 24 more minutes. Do you want to push on or do you want to call it and come back on Tuesday night? I'm here for another marathon anytime you want, Stu says. Corin Lewis, good to have you, Corin. Catalana, just to spur the moment because my last screen name was Kit Kat and was treated like a kid. Nice. You got to tell us the origin of that name. It's beautiful. Only 20 minutes. Okay, let's push on. Let's go to NGC 4781. NGC 4781. Ricky says, keep going. You're nice, Ricky. You know what I'm going to do next, guys, I think. You know, we're still working on the Caldwell list, so we can catch some of those. We're still working on Secret Deep, and we're still working on, let's see, we finished Messier, Secret Deep, Caldwell list. Oh, Hidden Treasures. Is that what it's called? Hidden Treasures. So we'll work on those 3 lists and complete those first. But after that, I think we're going to go with this Cosmic Challenge. This is a Phil Harrington book. You know, he writes for Astronomy Magazine. And what I like about this list, which he says, by the way, is the ultimate observing list, is it gives you more challenging objects near the end. You start out with easy, and you keep getting harder and harder. And probably there are going to be objects on this list that we've not done yet at all. In any of the other lists, I bet. That's my theory. So let's start working this one in when we catch up with Caldwell, Hidden Treasure, Secret Deep, and whatever else I said a while ago. Caldwell, Hidden Treasure, Secret Deep. Because we're going to be pretty much done with Herschel list, which has 400 objects. We're going to be pretty much done with this in like tonight. I mean, we'll have to come back and catch 3 more targets, maybe 4. 3 or 4 more targets. I bet we get one of them Tuesday night or Wednesday night. It's supposed to be clear again. So we're going to be done with the Herschel list, gang. And we need another list to have as an alternate. Right? So that's what we're going to try, is a cosmic challenge deal. This 4781 is for context, is still in Virgo. It's off to the right of the keystone, in between Corvus and the keystone. No astrophoto. 2 little stars there and a star there, make it into a nice, neat little arc. And there's the arc. Woohoo! $47.81. Barred spiral. Discovered March 25th, 1786. Dean Bostador. Thanks for being here, Dean. Kit Kat, give you a break. The Cone Nebula. Is this the Cone Nebula? I have to start at the beginning again. Ken, thank you. Thanks for being here. Is there an IC list? I'm sure there is. So clear to the west, Don. I'm nearsighted. Between the two of us, we can see eye to eye. Barred spiral. This is not the Cone Nebula, is it? Question mark, question mark. Is this the Cone Nebula? At 3 minutes was still pretty fuzzy. Oh, on the book, I see. The cover of the book, you're saying. This is a small target, man. 4781. 4781. 145. Small and dim. Difficult to fathom because 2 stars lie at its western flank. That would be these 2. Core is very round and surrounding lens only slightly elongated. 12th magnitude star west of the galaxy's nucleus. I guess that's that. Boy, not much there. Just a fuzzy patch. 12th mag star next to nucleus, fuzzy patch. Yes, we should be able to see that comet, Don. Dean, that's awesome that you come every chance you get. You're very kind. Got that on. I'm seeing planets but don't know which one's the west. That's Venus. Stu, good to have some new names with us tonight. Welcome to you all. Stu, that's nice of you all to welcome them. Stu always reminds us, if you'd like to subscribe, you can you can see announcements. In fact, if you hit the bell, then it'll alert you when we're going to do one of these live streams. And if you hit the thumbs up, it doesn't cost you any money, but it does work it up in the list everybody sees when they do searches. So we've got none of these other targets in this view, but quite a few galaxies. They're all very much like fuzzy patches, but Herschel saw this one. On to 4958. 4958. $49.58. No picture in Stellarium. Working our way down this keystone. Look, the moon has just come up. Dastardly moon at 89%. Don says, make sure you're hitting the like button and subscribe if you've not already done so. Catalino and Venus is so bright, right? Don, it's cloudy here tonight. No chance of meatballs, though. Guess I'll have to eat my zucchini bread. Stu, I'm looking forward to that comet, but it was discovered by a Chinese observatory. Has a very difficult name for me to remember and say. I bet we'll know it before it's over. Because it is supposed to be bright. I'm starting up my little heater down to 43 degrees out there. Maybe, if we're going to stay in Virgo for these, we could go without the plate solving. That would save us a little time, wouldn't it? Plate solving takes an extra couple or 3 minutes every target, huh? We'll start doing it without plate solving and see how we do. Moonlight is now starting to be a factor. You can already see it in the color matching. These galaxies, man. $49.58. 144. Very small, reasonably bright, well concentrated glow, 2 arc minutes wide. At 72 power, galaxy remains round, but the core increases dramatically to a star-like center. Large telescopes will show that the core is more lens-shaped. Under dark skies, the lens-shaped core is seated in a dim, tapered halo of feeble light that extends to nearly 4 arc minutes. That's what we're seeing, is like an eyeball. Like an eyeball of light. Pouring down rain, Tauranga. Temperature on Venus, 470 degrees Celsius on a cool day. Good alignment is all you need. Stu, hot enough to melt lead. Don, don't make anything out of lead. Hot enough to boil monkeys. Okay. Bright core. All right, off we go to, now this time we're not going to do plate solving, so we're going to say next target without plate solving. And it is 4995. 4995. Like an eyeball, right, Catalina? Monty Python thing. It's a nice view of the scope there, isn't it? You can see that rig rack up on top. See that that little assembly on top. Looks kind of like a JWST, whatever. That's, I mean, this outrigger. Not rig rack, this outrigger. It's on a little equipment plate, and it has the 178 Skycam that gives you these pictures. And it also has the USB distribution box and the power distribution box. Both of those are by Pegasus Astro. The Pegasus Astro micro pocket box and the Pegasus Astro USB distribution box. All right, here we go. Oh yeah. Lots of moonlight now. 89% moonlight. And this is 4995. Oh yeah, we already read this. Boy, the moonlight is wreaking havoc, isn't it? There we go. It is nice and round. This star here is 8th magnitude. Maybe both of those. Yeah, that's probably 8th magnitude. So that usually blinds it for people. Very dim objects, looks like asymmetrical foggy star. Faint round core, 1 arc minute wide, elongated haze, hazy disk with some irregularities. Hazy disk with some irregularities. Soft, faint core near 8th magnitude star. I like to laugh, really I do. It's an amazing night. Stu, the last 3 nights have been an amazing halo around the moon. It looked awesome, and yeah, like a huge eyeball looking down on us. Cool. All right, next, again, next target without plate solving is 4856. Probably that wasn't completely settled yet. Working our way down. This just looks like an orange star with a halo. That's it right in the middle. Look how it's got a star right beside it. (4856). (142). Tiny, somewhat obvious galaxy, nicely concentrated, easily spied with averted vision, star-like nucleus, core of light. Look how close that star is to it. (4856). Huh. So that must be that star right there. Hybrid solar eclipse coming up. First annular, then total, then finishes annular. Narrow band across the U.S. Catalana is in NorCal inland. Northern California, maybe. So Sacramento-ish. Bright. Four arc minutes. Halo. Small star beside nucleus. (2024) April 20th, only visible in Western Australia, New Guinea, and the ocean. 5 stars lined up on the right is fun. Oh, you're right. Like a satellite dish. Stu, gonna be just to the west of Doug, unfortunately. But I think we have one here coming April 8th of 2024. And it's coming right through our hometown. I bet that's the one you're talking about. I'll drive up to Freetown, Indiana, where I was raised. We still have a home place there. And I'll set up in our backyard. That's April 8th around 3 o'clock-ish in the afternoon, I think. Should be fun. All right, that's 4856. Now we're headed to next target without plate solving. 5054. 5054. It's the last galaxy in Virgo, by the way. Left, actually. Yeah, like the world changes just for a little while. Can understand why the primitives would have freaked out. Catalana, yes, Sacramento town soil, but that's the opposite of the universe. All right. For this last object in the galaxy of Virgo, just 5054, there it is. It looks like a round, faint star halo again. Just for context, we're now down completely at the end of this keystone. Kind of in a circle here with Corvus and Crater, huh? Okay, let's check it out. Bright moonlight now. If we define that moonlight out of the darkness, then all we see is the core. So we just have to take some of the moonlight in the picture. (5054). So clear to the west. Two in a row that Wikipedia doesn't have a page for. Wow, that's getting nondescript when Wikipedia doesn't even have a page. Getting low. Yeah, 12 degrees above the horizon, you're right. Azray, good pickup. I wonder if it'll tell us what the air mass is. .6 air masses. We saw this through 6.6 air masses. So that's like the equivalent of 6.6 atmospheres if we were looking at it at the zenith. Fairly fuzzy, but could see the core and the arms faintly. Want to hear the flat Earth explanation of a hybrid solar eclipse. That's good. All right, that's 5054. That's going to be our last galaxy in Virgo. Now we're headed to Lepus, which I think is a rabbit. Oh, target exceeds the limit. Oh, it's 8 degrees. How about that? Look at this, gang. So let's see. Let's go back to Stellarium and let's find something that we know where it is. Like, let's go to the Rose cluster. Make sure we're still tracking okay. Ricky's neighbor just asked if he believed the Earth was flat. Stu, SpaceX is launching 3 different rockets in 3 days next week. So excited. The biggest rocket ever made. I saw a thing about that. That is going to really be fun. This is the NGC 5904 for whatever it's worth. Huh. What in the world? Okay. Looks like the scope is able to travel back to the 0 position. Kind of go here and sort of get reset here real quick. The smaller second stage exploding was amazing. Can't wait for the huge booster. Virgin's going bankrupt. Yep, saw that. Chapter 11. 33, 34 on future ones. Hope all the tiles stay on Starship. All right, let's enable tracking again. Kind of start from scratch here and go back to this place in Lepus. No, it won't go to it. I guess because it's under 8 degrees. I must have some kind of a limit programmed in to this part of the sky, and it won't go to it. So that'll end tonight, and then we'll wait on this object to be a little higher next time. That means, back to the screen, that means we are back. I'm going to stop this. That means we are back to, let's see, let's ignore the objects by altitude and rerun. There might be 5 objects left. I think, seems like we've observed Sculptor Galaxy before. I'll have to go back and see if we've observed that under a different name. Maybe it has like something besides 253. And if we've got an observation of that, we'll count that. In this list, it shows we haven't observed it in this list yet, though. Depending on what we find on NGC 253, there are 4 objects remaining. So just 1% left of the Herschel list. I want to thank you guys for sticking with us. Night after night, you come back to these live streams. If you haven't subscribed yet, we'd love to ask you to do that. If that's what you want to do, it's up to you. Click the thumbs up if you like this, and if you didn't, you don't have to do that, but it doesn't cost you anything, and it does get us up in the searches that other people do. But click the bell if you want to be notified. We do have a website, emeraldhillskies.com. You can go there and you can sign up for an email and be alerted by email whenever we're going to do one of these. And we usually do that a day or so in advance, at least the morning that we're going to observe that night. We'll send out an email, sometimes 24 hours in advance if we can see the weather looks dependable. We'll send an email in advance. You can also go to YouTube and search for Emerald Hill Skies. It's actually youtube.com/@Emerald Hill Skies, I think. At YouTube, there is a store where you can buy Emerald Hill Skies merchandise. And that's fun for some people. You can click on that link to go to the store and you can grab hoodies and all kinds of things. Anything that you buy, if they do send us any money for it, and they do eventually send some money for it, we invest it in people that are hurting. Like right now, a lot of it, we've just sent it to Turkey, people that were in that earthquake. If you do a super chat or if you do one of those merch kinds of things, we also have a Patreon page. You can go to the Emerald Hill Skies Patreon page. It's just patreon.com/Emerald Hill Skies. And you could just commit to be a patron there. And that helps on a monthly basis. And again, none of that money, we don't take it personally. We're not trying to get rich here. We're not trying to make money off this. But we invest it for people who are hurting somewhere, refugees or immigrants or people that are in a disaster like the Turkey earthquake. You guys, we went over half an hour tonight to finish up as much as we can. Next time we come back, we'll clean up Caldwell list objects. We'll go to Hidden Treasures and Secret Deep by Stephen James O'Meara. We're continuing in those lists, and we'll tackle them probably this coming Tuesday night, something like 10 to 12. And this coming Wednesday night, we'll probably do back-to-back nights. They both look clear. Stay tuned. We hope you'll be here. I'll finish up by looking here. Acoustic energy from the launches. New company in New Zealand making rocket planes, Dawn Aerospace. Falcon launches. Yep, slew limits. I probably had it set on 10 degrees. 7 years today since SpaceX landed their first Falcon. Thank you, Azray. Happy Easter to everybody. You're very kind, Stu. Thanks for you being here with us. Dawn, you're very kind to encourage. Dean, thank you. Happy Easter. Thanks to the chat. Falcon Heavy next week. 2 boosters landing at once. So cool. Back at the Cape. So much fun when they land back at the Cape. Hey, one more time, I want to thank the Lord for making all these cool galaxies that we saw tonight. And I got to say here at the end, thank the Lord for making Easter, because that gives us tremendous hope. We can all hope for heaven because of what happens in what we celebrate tomorrow morning. Thank you, guys. God bless everybody, and we'll see you next time. Probably Tuesday night. Hope you're back. See you then.